My name is Brian Waddingham. I teach at Baxter High School. I teach agricultural education, and this is my 6th year. This activity is designed to teach students basic animal husbandry skills, how to take water quality tests. So what we do is we raise fish through aquaculture, and students are responsible for maintaining the water quality, tank system, cleaning and maintenance, recording the growth rate and size of fish. And one group is assigned to the greenhouse area, the other group is assigned to the aqua lab, and water quality tests are done such as temperature, pH, dissolved oxygen, and ammonia recorded, and then also with the fish growth we chart the progress there, jot it down in our record book, and at the end of the hour we bring it in and transfer it over to computer records. So we are able to see where our water quality is in our tanks over the course of the year. My goals for this unit would be teaching students basic animal husbandry skills, how to complete water quality tests, what polyculture is, how aquaponics is becoming a more dominant role in raising produce and fish in the United States, how to calculate rate of gain and feed efficiency, teach them just basic feeding practices for fish, and then try to tie it all in together as to how, just because they're fish, it does relate to livestock such as cattle and horses and hogs. Even though the requirements are a little different, it's still the basic principles that apply. As far as the lab work is concerned, I just monitor how hard they work, check the record book at the end of the week, and then if their area is kept clean and all the test kits and stuff are put away, that's another part of the assessment that I use. The activity that I do is basically the class itself. The actual activity as far as the water quality testing and the tank cleaning, the record keeping would probably take 45 to 50 minutes a block, which would still leave us roughly 30 to 40 minutes at the end where we are able to keep discussing various aquaculture. We don't actually have a textbook, I just have a series of other little things I pull out of the newspaper and magazines and stuff. We discuss aquaculture, the direction it's heading, but the actual course as a whole would take an entire year to run. I selected this particular teaching strategy as far as the hands-on approach to learning because I felt it really maintained student interest and it generated a lot of excitement amongst the students. And also I do teach ag ed, and out of my total enrollment, I think maybe only 10% are actually what you'd call farm kids. So really the production side of agriculture doesn't apply to them. So I was always looking for a way to show the other side of agriculture, and aquaculture was just one of the newer exciting things that I could get my hands on and we could actually perform here in our lab. And the students really seem to enjoy it, and it's just grown considerably the past 4 years since we started it. Current student characteristics affect this activity by, I only have 4 in the class right now, and all 4 of those are very much into the field of aquaculture, and they want to learn as much as they can. So they have a lot more freedom than, say, a class of maybe 18 where their interest level might not be as high. We may have to spend a little more time in the classroom getting through various material before I think they have the knowledge necessary to move into the lab. But as the information that they learn and they feel more comfortable with it, usually the more lab time I give them. But it's really up to the students as far as what they're allowed to do. And right now, like I mentioned, student interest is really high with this group, and they have a lot of freedom, and we're willing to try a lot of different things. They suggested the aquaponics, and so we went ahead and built an aquaponics setup, and we're raising lettuce and tomatoes with the largemouth bass to see what we can get done there. Content standards are evident. I think I do use a lot of the vocational education standards as well as with the water quality testing. There's a lot of science involved with that. Students also need to know numbers, so math would be another issue addressed there. And when it comes for the figuring rate of gain on the fish, obviously math plays a role in that. The water quality, once again, just looking at the water, you can kind of decide if there is a problem, and once again, a little science-related issue there. I think democracy is evident in this learning activity because students do have a little freedom to decide what they want to do, in what order they want to do things as far as feeding is concerned, the water quality testing, or tank cleaning. If a problem does arise, students, this group of students anyway, is they are very responsible for getting together, troubleshooting the problem, and then coming back together with a new answer and hopefully the right answer. They can try that, and if it doesn't work, once again they go back together as a group and can try to decide on the best way to fix the problem.